In the grand taxonomy of military aviation, few machines are as polarizing or as paradoxical as the Sukhoi Su-34. NATO, with its typical flair for imposing nomenclature, christened it the Fullback, a name that evokes an image of a stalwart, powerful defender. Its own crews, however, know it by a far less dignified, if more descriptive, set of nicknames. Utkonos, the Platypus, or Utyonok, the Duckling. This comical dissonance is the perfect introduction to the aircraft because one look at its bizarre, flattened, duckbill-shaped forward fuselage confirms that this is no ordinary machine. That strange nose is not an aesthetic indulgence. It is the physical manifestation of a radical design choice, a clue that what you are looking at is not truly a fighter at all, but a flying tank with the DNA of a heavy bomber, surgically grafted onto the high-performance airframe of the legendary Su-27 flanker. This is an aircraft designed for a very specific, brutal kind of war, a war of low-level, high-speed penetration under a hail of enemy fire. It was a concept born in the final paranoid twilight of the Soviet Union, and when it was finally asked to perform that exact mission decades later in the skies over Ukraine, it failed catastrophically. Yet today, the Su-34 dominates the ground attack mission, not because of its specialized armored nature, but in spite of it. Its story is not one of linear success, but of failed assumptions, a brutal crucible, and a late-life adaptation that turned a failed 1980s-era penetrator into a terrifyingly effective 21st-century standoff killer. The Su-34 story is one of a monumentally protracted gestation, a 24-year journey from its first flight in 1990 to its official entry into service in 2014. A gap so long it essentially guaranteed the aircraft would be an anachronism on its very first day of deployment. The requirement was born in the late 1970s and solidified in the mid-1980s, as the Soviet Air Force sought a modern, long-range successor to its impressive but aging fleet of swing-wing Sukhoi Su-34 Fencer tactical bombers. The ambition was to replace not just the Su-24, but also the MiG-27 and Su-25 in some roles, creating a single, versatile platform. The Sukhoi Design Bureau, buoyed by the resounding success of its Su-27 flanker air superiority fighter, selected that world-class airframe as the foundation for the new Istrebitel Bombardirovschik, or fighter bomber, designated Su-27IB. The project, known internally as T-10V, was a brilliant piece of engineering kit-bashing. The designers did not start with a standard Su-27. Instead, they selected the T-10KM2, the naval trainer derivative of the Su-27K, the future Su-33. This was a critical and deliberate choice. The naval flanker already possessed two features the new bomber would need: canard foreplanes for enhanced low-speed control and stability during carrier approaches, and a heavily reinforced undercarriage to withstand the trauma of hard deck landings. These features were a perfect match for a new aircraft that would need to fly stably at low altitude and take off with a massive increase in weight, soaring from the Su-27's typical 33,000 kilogram maximum takeoff weight to a staggering 45,100 kilograms. The first prototype, T-10V1, took to the air on April 13, 1990, just as the state that commissioned it was beginning to disintegrate. The collapse of the Soviet Union and the subsequent economic development hell of the 1990s shelved the program. It limped on, with a second, more representative pre-production prototype, T-10V2, flying on December 18, 1993. But for the next decade, the project languished. This 24-year gap is the Su-34's original sin. In the time it took to go from first flight to service, the entire paradigm of aerial warfare had changed. While the Su-34's advanced 1990s-era avionics, internal targeting systems, and passive electronically scanned array radar were frozen in time, the West had moved on, developing and fielding active electronically scanned array radars, network-centric sensor fusion, and modular targeting pods. When the Su-34 was finally introduced in 2014, it was a brand new old aircraft. The heart of the Platypus, and the reason for its unique silhouette, is its cockpit. The designers abandoned the traditional tandem seating of the Su-27 trainer and instead engineered an entirely new, wider forward fuselage. This aircraft is built around a side-by-side cockpit, placing the pilot and the weapon systems officer shoulder to shoulder. This configuration, reminiscent of bombers like the Su-24 it was replacing, was chosen to improve crew coordination and communication during complex, long-duration strike missions that could last 10 hours or more. It simplified the instrument panel, removing the need for duplicate displays, and created a bomber-style office for the complex work of navigation and weapon deployment. This office is perhaps the most literal example of the flying tank philosophy. The entire crew cabin is an all-welded titanium armored tub or capsule. This structure, reportedly 17 millimeters or 0.67 inches thick, adds a staggering 1,480 to 1,500 kilograms to the airframe, the weight of an entire car, just in armor. This bathtub was designed with one mission in mind: protecting the crew and critical avionics from small arms fire, shrapnel, and missile fragments during the high-risk, low-level attack runs its doctrine demanded. This extreme design choice had cascading engineering consequences. A 1.5-ton armored capsule cannot be opened like a conventional fighter canopy. It would be a structural impossibility and a massive, unarmorable weak point. Therefore, the canopy is completely sealed and pressurized. The crew enters the aircraft in a most peculiar way, via a retractable ladder that extends down from the nose wheel bay, forcing them to climb up through a hatch in the floor of the cockpit, just behind the ejection seats. This quirky feature is not a design indulgence, it is a necessary and perhaps awkward solution dictated entirely by the aircraft's primary requirement for an invulnerable, sealed cockpit. Egress is more conventional, with the crew protected by NPP Zvezda K-36 DM-00 ejection seats, which fire upwards after an explosive charge blows the main canopy clear. The sheer size of this forward fuselage also gave rise to persistent myths of crew luxury. The aircraft was rumored to have a galley and a toilet, features unheard of in a tactical aircraft. The reality, as one might expect, is far more primitive and speaks to the grim physiological demands of endurance. The galley is not a microwave, but a simple heating unit for warming cans of food. The toilet is not a porcelain throne, but a sanitary container, a basic metal canister with a cone-shaped aperture that functions as a urinal. The true comfort feature is not these crude amenities, but the volume of the space itself. The cabin is tall enough for a crew member to unstrap, stand up, stretch their legs, or even lie prone in the compartment behind the seats. This is not about luxury. It is the bare minimum ergonomics required to keep a human crew physically and mentally functional over a 10-hour mission, preventing the kind of fatigue that leads to fatal errors. To haul this 1.5-ton armored office and a massive bomb load, the Su-34's airframe required a brute force approach to engineering. It is powered by a pair of reliable and proven Saturn Lyulka AL-31 FM-1 afterburning turbofan engines, each providing significant thrust. This power plant gives the 22,500 kilogram empty aircraft the ability to reach a maximum takeoff weight of 45,100 kilograms. Despite its bulk, its performance remains impressive, boasting a maximum speed of Mach 1.8 at altitude and, more critically for its intended role, a formidable Mach 1.2 at sea level. The aircraft's key attributes, however, are its range and payload. It has a ferry range of 4,000 to 4,500 kilometers on internal fuel alone and a tactical combat radius of 1,100 kilometers with a standard weapons load. Its 10 to 12 hardpoints can carry a maximum payload variously cited between 8,000 and 12,000 kilograms. But it is not just a heavier flanker. The design incorporates two critical compromises that firmly place it in the bomber category. First, the aforementioned canard foreplanes are not just for fighter-like agility. They provide essential lift, and when combined with an active gust alleviation system, enhance stability for a smoother, less turbulent ride during high-speed, low-altitude flight. The second and most telling compromise is the use of fixed geometry air inlets. This is a major departure from the Su-27, which uses complex, heavy, variable geometry inlets to manage airflow at speeds above Mach 2. The Su-34's designers deliberately sacrificed this peak fighter performance. Fixed inlets are simpler, lighter, more robust, and less vulnerable to foreign object damage, making them ideal for operations from the less prepared or austere airfields that a tactical bomber might use. This choice clearly optimized the aircraft for reliability and efficiency at its intended low to medium altitude penetration profile, not for high-altitude air-to-air duels. Bizarrely, this 45-ton armored fixed-inlet bomber retains a G limit of plus 9G, a rating identical to a thoroughbred fighter. This design contradiction, stressing the entire massive airframe to withstand 9G maneuvers, reveals the kitchen sink nature of the requirements, a machine ordered to be both an indestructible tank and a high-agility fighter, carrying the immense weight penalty for both philosophies at all times. The Su-34's survivability was intended to come not just from its titanium hide, but from a comprehensive and integrated electronic fortress. The Platypus nose is packed with the large Leninets Sh-141, also known as B-004, multi-mode radar system. This is a passive electronically scanned array, an advanced technology for the 1990s that offers significant advantages over older mechanically scanned radars. It is heavily optimized for air-to-ground work, featuring crucial terrain following and terrain avoidance modes to allow for safe, high-speed, low-level flight, day or night. Its air-to-air capability, while secondary, is credible for self-defense, with a claimed detection range of 90 to 120 kilometers against fighter-sized targets. For precision strikes, the aircraft relied on the internal Platen electro-optical targeting system. This unit, which retracts into the fuselage belly, includes a television camera and a laser designator. However, it suffers from a critical generation-defining flaw. It lacks a thermal imaging channel. This restricts the Platen to effective use in daylight and clear weather, a significant limitation. This flaw is a direct consequence of the 24-year development gap. An internal system baked into the airframe in 1990 is a technological dead end, unlike the modular external targeting pods used by Western aircraft, which can be easily swapped out for new, upgraded models. The defensive suite is where the Su-34's bomber paranoia truly shines. Its primary electronic shield is the Kybany L-175V electronic countermeasures suite. Housed in distinctive large pods on the wingtips, the Kybany is designed to detect a missile launch, analyze the threat, and create a radio-electronic bubble of jamming to spoof the missile's guidance and deflect it from the aircraft. But the most unique component is in the tail. The prominent stinger or tail boom, which also houses an auxiliary power unit for balance, contains a rearward-facing N012 warning radar. This system, set to be upgraded to the Kopio DL in the Su-34M, is an electronic tail gunner. It is designed to detect threats such as enemy fighters or missiles approaching from the aircraft's vulnerable rear quarter. This comprehensive defensive suite, armor, a 360-degree jammer, and a rear-facing radar, confirms the aircraft's design philosophy. This is not a fighter. This is a self-reliant, lone wolf deep penetration bomber that expects to be on its own in hostile airspace and is built to survive the high-speed egress after dropping its payload. In the Global Strike Fighter Club, the Su-34 is a highly specialized member. It was born to replace the Su-24 Fencer, and compared to that capable but aging swing-wing platform, the Su-34 is a quantum leap in every metric: vastly superior range, a heavier payload, modern avionics, and an integrated self-defense suite. Its mission profile also invites comparisons with the European Panavia Tornado IDS, another twin-engine, two-seat aircraft specialized for low-level penetration. But its primary contemporary rival and philosophical counterpart is the American F-15E Strike Eagle. The comparison between the two illuminates a fundamental divide in design philosophy. The Su-34 is a bomber that can fight. It is a specialized, rugged, heavy payload strike aircraft, prioritizing payload up to 12,000 kilograms or more versus the F-15E's 10,400 kilograms and crew survivability, courtesy of its 1.5-ton titanium bathtub. Its significant air-to-air armament, including R-73A A-11 Archer and R-77A A-12 Adder missiles, is intended for self-defense, not for hunting. The F-15E, by contrast, is a fighter that can bomb. It was developed from the F-15 Eagle, arguably the greatest air superiority fighter of its generation, and it retains nearly all of its parent's formidable air-to-air lethality. The Strike Eagle has a decisive technological advantage. Its modern, active, electronically scanned array radars, like the AN/APG-82, are generations ahead of the Su-34's passive electronically scanned array system in range, resolution, and jamming resistance. Its modular external sniper targeting pods provide superior imaging and targeting capabilities day or night, in any weather, far surpassing the Su-34's daylight-only internal Platen system. In any head-to-head air-to-air engagement, the F-15E would be overwhelmingly favored. This comparison reveals a deeper 1980s versus 21st century doctrinal split. The Su-34 is the peak of platform-centric warfare, a self-reliant lone wolf that carries its own armor, its own jammer, and its own tail gunner. The F-15E is a node in a network-centric system. It is designed to share data, fuse sensor information, and use its superior sensors to avoid threats, not tank them. This philosophical gap would prove to be the Su-34's undoing. The Su-34's operational history is a tale of two vastly different wars, a story that begins with a narrative of success and descends into a brutal reality check. Its combat debut came in September 2015 as part of Russia's military intervention in the Syrian civil war. In the largely permissive air environment over Syria, where opposition forces lacked any meaningful air defense, the Su-34 was able to operate exactly as its designers had hoped, but in a way that was never intended at high altitude. It flew with relative impunity at medium to high altitudes, often above 5,000 meters, acting as a high-precision bomber. It successfully employed a range of guided weapons, most notably the KAB-500S satellite-guided bomb, against fixed targets. It looked like a modern, capable, and highly successful platform, a narrative that was heavily promoted by Russian media. This perception was shattered in February 2022. The full-scale invasion of Ukraine was meant to be the Su-34's proving ground. Instead, it became its crucible. The Russian aerospace forces, in a stunning display of doctrinal failure, did not effectively conduct suppression or destruction of enemy air defense operations. Ukraine's mobile, networked, and modern-supported air defense system remained active, denying Russia air superiority. This forced the Su-34 fleet, which numbered around 124 aircraft at the start of the war, to perform the 1980s-era mission for which it was originally terribly designed: low-altitude, unguided, dumb bomb strikes. The results were catastrophic. Forced down into the lethal envelope of shoulder-fired man-portable air defense systems and short-range mobile surface-to-air missiles, the flying tanks were systematically hunted. The 17mm titanium bathtub, designed to stop rifle fire, was utterly useless against a direct hit from a 21st century missile. Dozens of Su-34s were confirmed lost, with open-source analysis visually confirming at least 33 to 41 losses by 2024 to 2025. The flying tank was a myth, and the original concept was a death sentence. Then, facing catastrophic losses, Russia adapted. This adaptation, born of desperation, is the true source of the Su-34's modern-day dominance. Russia began mass-producing the UMPK, or Unificirovanny Modul Planirovania, i Korekcji, the Unified Gliding and Correction Module. This is a JDAM on a budget, a simple, cheap kit that straps a set of pop-out wings and a satellite navigation receiver to Russia's vast stockpiles of old FAB-250, FAB-500, and even the massive FAB-1500 dumb bombs. This crude innovation was a game-changer. The Su-34's mission changed overnight. It was no longer a low-level penetrator. It was reborn as a high-altitude, standoff launch platform. From the relative safety of high altitude and 40 to 90 kilometers away from the front lines, Su-34s began to rain down a storm of these newly guided bombs. The volume is overwhelming. By 2024 to 2025, Russia was dropping an average of 100 to 160 of these glide bombs per day. During the battle for Avdiivka, they dropped 250 in just 2 days, utterly pulverizing fixed defenses. This is the Su-34's new brutal form of dominance, a dominance of volume, brute force, and standoff range. This success, however, is a profound indictment of its original design. The Su-34 is not dominating because of its unique, specialized features. Its 1.5-ton titanium bathtub is now 1.5 tons of dead weight, uselessly hauled to 40,000 feet, actively reducing its payload and range. Its fixed, low-level inlets are an aerodynamic inefficiency. Its rear-facing radar is irrelevant. The Platypus dominates in spite of its design, not because of it. It succeeds by leveraging the only attributes that still matter: the generic sound engineering of its flanker heritage, which gave it a large, robust airframe with the long range, high endurance, and heavy payload capacity needed to become a flying artillery truck. The story of the Su-34 is not over. Its failures have forced a rapid, wartime evolution. The Su-34M, or NVO, modernization program is in full swing, with new batches of upgraded aircraft being delivered to the VKS to replace losses and enhance the fleet. This upgrade aims to fix the avionics, radar, and targeting weaknesses exposed by the war. The most significant change is the integration of the Psyche, or Little Owl, universal reconnaissance pods. This new modular system finally fixes the critical vulnerability of the old internal platen. The pods come in 3 distinct variants, allowing the Su-34M to become a true reconnaissance strike platform: the UKRRL, with a side-looking radar, the UKRRT, with a signals intelligence package, and the UKROE, with modern electro-optical and infrared sensors. This allows the aircraft to find its own targets and attack them in a single sortie, a capability it desperately lacked. In a final crowning irony, this Psyche pod represents a complete reversal of the Su-34's original design philosophy. The platform, once defined by its baked-in internal systems, is now being saved by external, modular pods. It is a tacit admission by Russian engineers that the Western design philosophy of modularity, as seen on the F-15E, was correct all along. The Su-34's story is the ultimate lesson in military adaptation. It was a machine built on a failed 1980s philosophy, a flying tank that proved all too mortal. But its fundamental airframe was so sound that it could be reborn. It now dominates the battlefield, not as the invincible, low-level penetrator its designers envisioned, but as a heavy, high-altitude, and brutally effective bomb truck, a platform perfectly, if accidentally, suited to the attritional standoff warfare of the 21st century. Yet the Su-34's transformation raises uncomfortable questions about the future of tactical aviation itself. The aircraft's current success is built entirely on exploiting a technological asymmetry that may not last. Ukraine's air defense network, while effective against low-altitude threats, has struggled to intercept these high-altitude glide bomb attacks due to a critical shortage of long-range surface-to-air missile systems. The arrival of Western systems like Patriot batteries has demonstrated this vulnerability starkly. When properly equipped interceptors are positioned to cover the launch zones, the Su-34's immunity evaporates. The aircraft is forced either to launch from even greater distances, drastically reducing accuracy and payload efficiency, or to accept prohibitive losses. This exposes the central paradox of the platform's current role. The Su-34 has become extraordinarily successful at a mission that requires almost none of its specialized design features, while simultaneously proving unable to survive in any scenario that would actually demand those features. The titanium bathtub, the sealed cockpit, the rear-facing radar, all of these expensive, weight-intensive systems are evolutionary dead ends, artifacts of a doctrine that assumed penetration was possible and standoff was cowardice. Modern reality has inverted this assumption entirely. Standoff is survival. Penetration is suicide. This realization is reshaping Russian tactical aviation doctrine in real time, and the implications extend far beyond the Su-34 itself. The Russian military-industrial complex is now caught in a strategic dilemma. The Su-34M upgrade program, while addressing critical sensor and targeting deficiencies, cannot remove the fundamental weight penalties baked into the airframe. Every kilogram of titanium armor, every cubic meter of oversized, side-by-side cockpit volume, every structural reinforcement designed for 9G maneuvering at 45 tons represents payload capacity that could instead be carrying additional weapons or fuel. A purpose-built standoff striker, designed from the ground up for high-altitude glide bomb delivery, could theoretically carry 30 to 40% more ordnance over the same distance or achieve significantly greater standoff ranges with the same payload. Such an aircraft would be lighter, more fuel-efficient, require less maintenance, and cost substantially less to produce. It would also be utterly defenseless if forced into low-altitude penetration or close-range air combat. But the Ukraine war has demonstrated that these scenarios are suicidal, regardless of armor protection. The question facing Russian planners is whether to commit to an entirely new design philosophy, abandoning decades of platform-centric doctrine in favor of network-centric, standoff-optimized platforms, or to continue upgrading and producing the Su-34, accepting its inefficiencies as the price of maintaining a theoretically multi-role capability that will likely never be used again. This dilemma is compounded by industrial and economic realities. Russia's aviation industry, heavily sanctioned and cut off from Western components and manufacturing technologies, lacks the capacity to rapidly develop and field an entirely new airframe. The Su-34 production line is mature, relatively reliable, and critically already exists. The institutional knowledge, the tooling, the supply chains, the trained workers, all of these represent sunk costs that would be lost with a clean-sheet design. Moreover, the Su-34's flanker heritage means it shares substantial commonality with other Russian combat aircraft, simplifying logistics, training, and maintenance. Developing a new platform would require a decade or more, during which Russia would be forced to continue producing an admittedly suboptimal design or accept a significant reduction in tactical strike capability. The path of least resistance, then, is to continue the Su-34M program, incrementally improving sensors, weapons integration, and defensive systems, while quietly accepting that the aircraft's signature features, the very elements that define it as the Platypus, are now obsolete baggage. The broader lesson of the Su-34's evolution extends beyond Russian aviation. It serves as a cautionary tale about the dangers of over-specialization and the unpredictability of future warfare. The aircraft was designed with exquisite attention to a specific threat environment: low-altitude penetration against Cold War-era air defenses, followed by high-speed egress through a predictable, relatively static threat envelope. This mission profile was rendered obsolete not by a single technological breakthrough, but by the cumulative effect of multiple evolutionary changes: more mobile and networked air defenses, man-portable surface-to-air missiles with dramatically improved seekers and range, ubiquitous satellite navigation enabling precision guidance for cheap munitions, and the proliferation of sensor networks that make low-altitude penetration tactically suicidal. The Su-34's designers could not have predicted this specific combination of threats, but they made the platform's survival dependent on assumptions that proved fragile. The Western approach, exemplified by the F-15E and platforms like the F-35, embraced modularity and adaptability. External pods, software-defined mission systems, and network-centric architecture allow these aircraft to evolve their capabilities without fundamental redesigns. The Su-34's hard-baked, platform-centric design left it trapped, unable to adapt quickly enough to a rapidly changing battlefield. Yet, for all its flaws, the Su-34 endures, and in its own brutal way, it thrives. This endurance is testament not to the brilliance of its original concept, but to the robustness of the underlying flanker airframe and the desperate ingenuity of adaptation under wartime pressure. The aircraft has become a symbol of a broader truth about modern conflict: that wars are not won by the most sophisticated technology or the most elegant doctrine, but by the side that can most rapidly adapt, learn, and exploit whatever advantages are available, no matter how crude or inelegant. The Su-34, shedding its pretensions of invulnerability and accepting its new role as a simple, high-altitude bomb truck, has done exactly that. It survives not as a vindication of its designer's vision, but as a monument to pragmatism, a platform that succeeded by abandoning everything that made it unique and embracing the only qualities that truly mattered. In the skies over Ukraine, the Platypus flies on, no longer a flying tank, but a flying warehouse, and in that unglamorous role, it has found a terrible, undeniable effectiveness.